Hello everybody, welcome back. Yesterday we talked about how we can take the parent function of our parabola, y equals x squared, and we can start moving it around by putting numbers either outside the parentheses or inside the parentheses, just like we did way back when we were talking about absolute value functions. Let me make my eraser a little lot bigger there. So let's take a look at these two just to get ourselves thinking back into what we were looking at yesterday. Okay, so first one, we have not only our graph, but we also have our equation. So we could tell from the graph, well, let's find our vertex. Normally it's at 0, 0, but now it looks like it is back 1, 2, and up 1, 2, 3, 4. So it looks like our vertex is at -2, up 4. Well, that also talks about how we moved our parabola when we use those numbers. And remember, if it's inside the parentheses, +2 inside, we're going to move the opposite way, right? Inside the parentheses was our left, right. Since it's +2, I'm going to go to the left 2 spots, okay? And the one outside the parentheses is our up and down. This was our left and right. And our up and down moves just like we think it would. So it's going to go up 4. And then the last thing, we've got a negative sign out there. So that means that this is going to be flipped, which is something we see in the graph as well, right? Normally it faces up. Now it's facing down. What's our vertex? Well, we already found that. Left 2 means -2. Up 4, +4. There's our vertex. All right, we talked a little bit about domain yesterday. Domain is easy. Domain is always all reals for our parabolic functions. Range. Range deals with our y's, okay? Range deals with our y's. So the highest the y is ever going to get here is at 4, right? Y is, or 4 is going to be the highest to get. So I know I have y. I know I'm dealing with a 4. And then I'm saying, do I get the numbers above or the numbers below? Well, since it's facing down, I get the numbers below. So y is less than or equal to 4. There's our range. All right, now looking at example number 2, where it doesn't have the graph, I can still tell what the transformations are going to be. Remember, inside the parentheses, this is my left and right. -1, it's the opposite of what I think that should mean, so this must be going right 1. +5 on the outside is my up-down number. +5 means it's going up 5, so my vertex, right 1, up 5 is at 1, 5. All right, let's turn our attention to some new things. But again, before we do, let's just kind of touch base on, this is a slide that I put up yesterday. We've looked at now what H does. We've looked at what K does when we write things in vertex form, okay? Vertex form is our new form. We know what H does. We know what K does. This moves us left and right. This moves us up and down. Vertex is going to be at H and K. So quick and easy, my vertex here is going to be, well, this is going left 5 and up 2, or down, sorry, and down 2. So we're going to be at -5, 2 for our vertex. And I'm giving you this slide again. Where we stopped yesterday, though, is the only thing we really looked at for the A value right here and here is if it was negative or positive. And if it was negative, it flipped upside down. If it was positive, it opened up. Well, that's what I want to talk some more about today, because more than just being positive or negative, A can have effects on a graph. So here's where I want to start. I just want to start with our parent function. I'm just going to add a t-table right here. And let me just pick some numbers right around 0. So x is equal to -2, -1, 0, 1, and 2. And I'm just picking a few numbers. Now, 1 I know is really easy because I know the vertex of my parent function's at 0, 0. So if I plug in 0 for x, I'm going to get 0 for y. So I know I have a point right there at 0, 0. Okay. All right. Well, let's plug in -1 for x. -1 means y is -1 squared, which is equal to 1. Well, same for 1. 1 squared is also equal to 1. So here's one thing I always noticed on parabolas. I had my vertex. If it was just the regular function here, I went up 1 over 1 to the right, and I went up over 1 to the left, and up 1. And remember, since we've got our axis of symmetry running right down the middle of our graph here, because remember that axis of symmetry has to go through our vertex, we're going to see things like this, where it's like those 2 points are looking directly into the mirror at each other. Well, let's try -2. -2 squared is equal to 4, and 2 squared is equal to 4. So not surprisingly, we're also going to see 2 points that are looking in the mirror at each other. So on a parabola, I'd go from my vertex. Over 1, up 1, there's a point. Over 1, 2, up 4, or back 2, up 4, there's going to be 2 more points. And again, they're looking into mirrors at each other. So you kind of start to see the pattern of what's going to happen, let's go with purple, with a parabola that's just y equals x squared. And I'll point out, and we'll talk a little bit more about it tomorrow, but even if I move this vertex, let's say I moved this vertex, and let's go back up here, and I moved my vertex to -5, 2, I'm still going to see the same pattern. Over 1, up 1. Back 1, up 1. Over 2, up 4. Back 2, up 4. My question then becomes, since this is the only thing that we haven't talked about yet, is what happens when I start putting numbers in here for a? What happens when I put numbers in front of that x squared? All right, so here's what I've done. Before we got this going, I just went ahead and plotted points, and I went all the way back to -3 and +3, just so you can see the pattern. Let's see what happens when I put a 2 in front. All right, well, that means 2 times -3 squared is y. -3 squared is 9. 2 times 9, 18. All right, 2 times -2 squared. Well, -2 squared is 4 times 2, 8. -1, so 2 times -1 squared. -1 squared is 1 times 2 is 2. 2 times 0 squared, well, that's still just 0. And, not surprisingly, you're going to see the same pattern happening on the other side, which should not come as a surprise, because we know that each of these points is like looking into the mirror with our axis of symmetry running right down through our vertex. All right, so our vertex, speaking of our vertex, didn't change. It was still at 0, 0. But now, when I go back 1 and right 1, I'm going to go up 2 instead of 1. Over 1, up 2. Back 1, up 2. Okay, what about when I go back 2 into the right 2? This time I'm going to go up 8. Over 2, up 8. Back 2, up 8. Okay, again, those points are looking into the mirror being our y-axis because the vertex is at 0. And let's grab our last 2 points. Back 3, I'm going to go up 18. Forward 3, I'm going to go up 18. So over 1, 2, 3, up 18. Back 1, 2, 3, up 18. So now you can start to see what's going to happen. Let me grab my blue highlighter here. When we add the 2. It's going up faster, and that makes sense. It's going up 2 times as fast, right? All right, let's see what happens when we plug in the 3. All right, 3 times -3 squared, that's 27. 3 times negative 2 squared, well, that's 12. 3 times negative 1 squared is 3. Still going to be 0, and I won't do the rest, but it's going to follow the same pattern. So here's my vertex, 0, 0. Now when I go left 1 and right 1, I go up 3. Notice what's happening. These are all being stacked right on top of each other. Okay? Over 2 up 12. Over 2 up 12. Back 2 up, up 12. I missed that spot there. Back 2 up 12. Okay. And over 3 up 27. I can't even get that on my graph because it's too high. But if I now highlight these points, every time I put a number in front, and as you can kind of see already, the bigger this number is, the faster it's going to go up, and the closer and closer it's going to get to that y-axis, right? The widest one was our parent function. I added a 2, it crunched in a little bit. I changed that to a 3, it came in even more. It's getting narrower and narrower. Well, what if we flip the script here and we start taking things that aren't bigger than 1, but are smaller than 1? What if I start putting, say, like a fraction or a decimal in front there? Well, let's give it a shot. Purple marker. All right. Well, -3, we have 1/2 times -3 squared. Well, okay. Still going to be 0, 0. -3 squared is 9, divided by 2 or times 1/2 is 4.5. All right, 1/2 times -2 squared. -2 squared is 4, times 1/2 is 2. 1/2 times -1 squared, that's going to be 1. So this is 1/2, or I'm just going to write it as 0.5. All right, 0, 0, and 0.5 to 4.5. All right, these are going to be tiny points. Let's see what I can do with these. 0, 0, over 1, up 1/2, back 1, up 1/2, over 2, 1, 2, up 2, back 2, up 2, over 3, up 4.5, 1, 2, 3, up 4.5, back 3, up 4.5. All right, let me grab my highlighter. This now isn't going inside my old parabola, it's going on the outside of my old parabola. Okay, let's just check this last one here. I'll start at 0, 0. 0 squared, 1/3 times 0 squared is just 0. We knew that. 1/3 times -1 squared is 1/3. 1/3 times -2 squared, well, that's 4 over 3, so 1.3 repeating, so 1 and a little bit more. 1/3 times -3 squared, -3 squared is 9, times 1/3 is 3, and our values will repeat. Don't worry if you're not 100% seeing the values I'm getting here. We're going to talk more about graphing this stuff tomorrow. I just want to be able to get these and have you kind of visualize what's going on. All right, so my vertex still at 0, 0. Over 1, up 1/3, so even lower than that 1/2 I put last time. Over 2, up just 1 1/3, so about right there and right there. Over 1, 2, 3, up 1, 2, 3. So there and there. And notice what's happening. This graph is going outside again. So, compare and contrast. When we put numbers that were greater than 1 and are greater than 1, they started getting narrower and narrower. When I put numbers that were fractions between 1 and 0, right? Not negative numbers, but between 1 and 0, they were getting wider. It's making this more and more wide compared to the parent function. So how does the width of parabola? What does the number do? Well, here's a good example. Parent function's the one in blue. A number with a positive bigger number in front narrows it down. A positive fraction or a number smaller than 1 is going to put it that way. Now, it's same thing is going to work the other direction. If this was a negative 5 instead of a 5, it would still be narrower. It would just face downward. If this was y equals negative x squared, it would just face down. If this was y equals negative 1/5 x, it's still going to be wider. It's just going to go outside. So what we're really saying is if the absolute value is less than 1, right? So we're talking about numbers between 0 and 1. We're talking about those numbers, decimals, positive or negative, decimals and fractions between 0 and 1. Those are going to make our graph wider. Anything outside of that, the absolute value of the number is greater than 1, even if it's negative, right? Negative 2, negative 3.5 are fine, but as long as they are numbers that if I took the absolute value 1 and on, they're going to be narrower. They're going to get in between the lines. All right, so then I could look at something like this and say, all right, I want to list these from widest to narrowest. So the widest one will be 1. All right, so here's what I'm going to do. I'm just going to look down the line, and I'm just going to highlight all of these because that's all I'm going to be looking at. Okay, and I'm looking for the biggest number. Or I'm sorry, I'm going to look for the smallest fraction at this point. The smallest fraction, the number that is closest to 0. All right, well, there's a 0.75. There's a 0.2. There's a 0.3, and there's a 0.5. And remember, I don't care about the negative or positive. That just is facing up or down. So what's the smallest decimal? 0.2 is my smallest. So this one is going to be my widest, right? The closer that number is to 0, the wider it is. 0.3 will be my next. 0.5 would be my next. And 0.75 will be my next. Okay, now I'm all out of fractions. So now I'm just looking, let me switch up colors here. I'm looking for numbers that are the biggest, okay? So I've got 5. Let's put them out here so I don't confuse them with the other ones. I've got 5, I've got 8, I've got 10, I've got 1, because again, I don't care about the negative. All right, so the biggest number is going to be my narrowest. So if I keep going up from widest to narrowest, 1 will be my next one, then 5, then 8, and then 10. Basically, from a wide to a narrow, these are my really, really, really big numbers. These are my tiny numbers. Okay? That's how I'm looking at these. So let's just talk transformations quickly. Review of yesterday, see some of the stuff from today. Okay, this one, as far as transformations go, I don't have a number out there, so I don't need to worry about wide or narrow. It's not negative, so it's not flipped. All I need to worry about this. It's inside, so that means it's my left or right number. And I think opposite, so this is going to go left 8. So my vertex, which one is my left or right? Well, that's my x. So -8. I don't have any up and down number, so it'll be 0. All right, again, nothing in front, so I don't need to worry about a flip or net wider or narrower. I've got a number. It's outside, so this is my up-down number. Negative, so that means, just like I would think, down 9. I didn't move left or right, so my x is 0. I did move down, so my y is -9 for my vertex. Okay, I've got a negative out here. Negative, all that means is that I flipped this thing over. So this is flipped. It normally faces up. This one's facing down. +3 on the outside of parentheses. So that is my up-down number. And it goes just like I would think, up 3. My vertex, I didn't have a left or right, so that's going to stay 0 for my x, up 3. And lastly, again, nothing in front. My left-right numbers here. Okay, that means left, oops, I'll write it over here, left 1. Up-down number right here. I'm going to move with the number, so that's down 2. Left 1 is -1. Down 2 is -2. All right, last but not least, these three where I did put a number out front. Okay, it's not negative, so it's not flipped, but it's a 3. Because that is a number bigger than 1, this is going to narrow. It is going to get narrower. Number inside my parentheses is my left-right number. Outside is my up-down number. Left-right moves in the opposite way, I would think. So this is going right 1. Outside the parentheses moves just like I think. Down 7. Vertex, right 1 means it's at 1. Down 7, -7. I've got a number, 2/3. That number is smaller than 1. Since it's smaller than 1, it's in between 1 and 0, and 0 and 1. It's in between there. This is going to get wider. And I've got a number outside the parentheses. That's my up-down spot. So it's going to go up 6. Vertex, I didn't have any left or right motion, but I do have an up 6. So I'm going to put 6 there. All right, last one, and this is a tricky one. This is a tricky one. I'm trying to fool you because I put a fraction there. But what is 3/2? 3/2 is 1.5 or 1.5. That number is bigger than 1. So since this is greater than 1, this is going to get narrower. You're looking to see if that number is between 0 and 1 or bigger than 1. And if it's bigger than 1, it's narrower. And again, still outside, I can use 2 6s in a row. This is going to go up 6. This is my up-down number. So my vertex again will be at 0, 6. All right. Homework assignment for the night is called Transforming Quadratic Functions Worksheet. I posted it in Schoology. Feel free, use my office hours if you have questions about any of this.